Good morning, good afternoon, or good evening, depending on time of the day you are watching this video. In this video, we'll discuss IPSec VPN. We are going to cover this IPSec VPN in three different parts. In part 1, we are going to cover the concepts of IPSec VPN. And in part 2, we'll look into a configuration of IPSec VPN in a Cisco IOS router. And in part 3, we'll look at how do you configure IPSec VPN between two different type of devices, either a Cisco router and a Juniper device or any other third-party device. So let us get started. So what is VPN? Before I cover what is VPN, let us look at what is a private network and what is a public network. So private network is a network which is limited to within one organization. So what that means is that you could use the private IP address space within a private network. Because only employees of that specific organization are going to use it. Also, no one from outside should typically have access to the private network, so it's likely to be more secure. Your data is relatively more protected, and you could use your sensitive data with less security technology being used within a private network. Whereas a public network is like internet or any shared network provided by service provider, where multiple organizations or any individuals can use the same network. So by definition, public network is going to be less secure because there are a lot of data that passes through, and anybody could potentially access other organizations' data. So you need to take a lot more security precautions in a public network. So what is VPN? VPN is really a private network, but it's kind of a virtual private network. What that means is it's a private network, but this private network is running over a public network. One example is, say you are working from your branch office, and your branch office is connected to internet, and then your headquarters is also connected to internet, and then you are communicating between your branch office and headquarters. And then when you communicate from branch office to headquarters, this information needs to pass via internet, so it's passing via public network. So now you can use VPN technology to make sure that you're able to securely communicate between two offices over this public network, and you need to use some technology like VPN to do that. So broadly, there are two types of VPN. First, I will classify them as a clear text VPN. Some of the very commonly used clear text VPN today are MPLS VPNs. MPLS VPN itself has multiple types: L2 VPN, L3 VPN, VPLS. If you go to service provider, many service provider offers MPLS VPN services to their customers these days. So instead of having your dedicated link between your branches, you can take MPLS VPN from your service provider. There used to be a number of other protocols which are typically clear text. And for example, L2 forwarding, L2TP, L2 layer 2 tunneling protocol, PPTP, point-to-point tunneling protocol. These are some examples of mostly from client to site VPN protocols, and many times they are by default actually are clear text. You could add security on top of this, but normally they are clear text. And then example of secure VPN is IPSec and SSL. In this video, or in this series of videos, we'll mostly look at IPSec. What is SSL? SSL is Secure Socket Layer. SSL is a protocol that's typically used with HTTP. If you're going to a secure website, normally you are using SSL. So we look at IPSec in a little bit more detail. So before I get to IPSec, this is a diagram where I kind of for representation of what the VPN means. So here what you see is on the left to R1, you have a network which is a private network. We are using 192.168.1.0 IP address space here. On the right of R2, we have another private network which is using 172.16.1.0. Now these two networks, if they have to communicate over each other, in this case they don't have direct interconnect, they have a connection using a public network. And in public network, you need to use a public IP address. 171.1.1.1 is at one side that of the router we have a public IP address. Similarly, 2.2.2.2 is another public IP address. So this network, now in this network, if PC1 has to communicate to PC2, they cannot communicate directly using their original IP addresses. So one solution is you could NAT these IP addresses to a public IP address in R1 and R2. That works okay, but from user perspective, if they're using PC2, now they can't access the PC2 using their original IP address. They need to change the IP address. So experience is not same as accessing from a private network. So that's first part. Second is, if you are communicating some sensitive information between PC1 and PC2, now this information is passing via public network. So you have a security risk if you communicate it in clear text. So what you could do, you could create a VPN between R1 and R2, and the traffic from your network on the left side and network on the right side can communicate using this VPN. So if you use tunnel mode VPN, most likely if you're using a site-to-site VPN, you'll use tunnel mode. What's going to happen is, let's say your PC1's IP address is 192.168.1.10 and PC2's 170.16.1.10. So when PC1 wants to communicate to PC2, it will send an IP packet with a source address of 192.168.1.10 and a destination IP address of 170.16.1.10. But you cannot use this IP address when you are going to public network. So what happens is, once this packet reaches R1, what R1 is going to do is, R1 is going to tunnel this packet inside another IP packet. It's going to add an additional IP header with a source IP address of R1's IP address and destination IP address of R2's IP address, that is 2.2.2.2. So any device in between, when it receives the packet, it will see that this packet needs to go to 2.2.2.2 and it's going to route that to 2.2.2.2. So this mechanism is called tunneling, because as the packet exits R1, and it will come out via R2, because original IP address has been encapsulated inside a new IP header. And then once the packet reaches R2, R2 will see that this packet is for itself. It's going to look inside the IP protocol header, and it will understand that this is a VPN traffic, and it's going to remove the original IP header and then route the original packet into the internal network, and it will eventually reach PC2. So that's really how tunneling works. Now we'll look at a few terminologies and a little bit more around IPSec VPN. So IPSec VPN offers you three type of securities. So it offers encryption. What is encryption? If you want to know more, you could look for my previous video around security terms and concepts from Pragyan Technologies. Now, what is an encryption? Encryption is a technology which offers confidentiality. So your data, clear text data, once it's encrypted, it becomes ciphertext, and the people in the public network will not be able to understand that data anymore. And then payload verification offers you integrity, and the authentication makes sure that the data is coming and going to the right sources. Your VPN is between the right devices. And for IPSec, you have two choices. There are two protocols that you can use to implement IPSec. So IPSec is typically a protocol that runs over IP. It's a protocol based on IP, but it's still really a layer 3 protocol, because it offers layer 3 data transfer end-to-end. So the two options that you have to implement IPSec are ESP, or Encapsulated Security Payload, IP Protocol 50, or AH, that's IP Protocol 51. If you use ESP, ESP will offer you encryption, integrity, as well as authentication. But if you choose to use AH, encryption option is not going to be available. You can still ensure integrity and data origin authentication with AH. So of course, that means that if you want to, if encryption or confidentiality is your requirement, you are going to use ESP. So let's look at the different modes of IPSec. So IPSec operates typically in two modes. Two modes are available. You could choose either of them. That way you could choose ESP or Edge. Similarly, you can choose tunnel mode or transport mode. Well, you know, tunnel mode and transport mode, you cannot really choose kind of in any scenario. There are some scenarios when you would use tunnel mode where you can use transport mode. So what is tunnel mode? Tunnel mode is what we have spoken previously in a couple of slides back, right? If you are creating site-to-site VPN, for an example, if you have private IP addresses, you want these private IP addresses to be put inside a new header of public IP addresses. In that case, you are going to use tunnel mode. So what happens in tunnel mode? You have original IP packet, IP header plus data, and then in tunnel mode, your whole of original IP packet is going to be encrypted, including the IP header. And then a new IP header is going to be added, and the new IP header in this case is going to have IP address of the gateway. If you remember the previous diagram, in our diagram, the new IP header will have source IP address of 1.1.1.1 and destination IP address of 2.2.2.2. Your original IP addresses of PC1 and PC2, they're going to be inside this IP header, which is already encrypted. And then you're going to add in between your IPSec header, which is going to be either ESP or Edge header, depending on which protocol you are using. So if you are using transport mode, then how it's going to be look like, right? In transport mode, your original IP header remains as it is, and your only the data section is encrypted, and then you inject your IPSec header in between. So that's really the difference between transport mode and tunnel mode. So what this means? What this means is, if you have to use tunnel mode, your original IP addresses should be routable end to end. Let me go back to this diagram. If you have to use tunnel mode, transport mode here, then this IP address and this IP address should be routable across, so that the public networks can route packets using these IP addresses, right? So, well, if you're doing a site-to-site VPN, you're probably going to use tunnel mode all the time, right? One example of where you'll use transport mode is if you've already done some other form of tunneling. For example, GRE over IPSec. So in some cases, some vendors, they rely more heavily on GRE. So if you've already done a GRE tunneling, your original IP address has been encapsulated inside a GRE packet, then you may not want to do second level of tunneling once more. So you could just do a transport mode IPSec in that case. Now we look at how IPSec kind of a tunnel gets established. So when it comes to IPSec VPN, so there are typically two key steps. One is, once you configure the VPN tunnel needs to get established. What does VPN tunnel establishment means? It means that both the ends are agreeing on what parameters is going to use to for the VPN, right? So it's also called establishing security association. So we look at what are the parameters, but the first part is you need to make sure that both sides establishes that security association or tunnel. Once tunnel is established, then as your data packet comes in, data packets are going to be encrypted using your IKE or ESP or AH protocol. So data traffics are transported using ESP or AH, and your VPN tunnel establishment happens using a different protocol. So you have two choices. One is you could do a manual tunnel establishment. Then you need to manually define every parameter, right? You manually have to define exactly one protocol which matches on both the sides. If you have to do encryption using triple dash, you'll say that encryption is triple dash here. On the other side, you'll say triple dash as well. Then you'll have to say what is the key you are going to use for encryption, and the key should be on both the sides the same, right? So symmetric encryption key for triple dash. So similarly, you need to define every parameters. And then that means this parameter is going to be static. You probably have to periodically change them manually again, so it really doesn't scale. So what is your second choice? Your second choice is you use IKE, Internet Key Exchange Protocol, to have this negotiation happen automatically. You still need to define key parameters that are acceptable, but both the VPN ends, they will be able to exchange information between each other, and they will be able to agree on the final parameters that VPN is going to use. So that's what is IKE. So IKE is very, very crucial, because you are rarely going to use the manual VPN, and then most of the time the VPN related issues are likely to be IKE negotiation issue, and which might be because of your configuration though. So IKE itself has two versions, version 1 and version 2, right? So version 1 is what has been used for a very long time, and it continues to be used widely, and version 2 is getting adopted more and more now. So in this session we are going to cover, we are going to focus on version 1. So how IKE works? So as we said, the IKE job is to establish the tunnel. Once the tunnel is established, IKE does not have a lot of role to play for actual transit traffic. IKE could still monitor the VPN if you want, but the actual transit traffic, encryption and decryption security, IKE does not have any more role. So so IP packets themselves are different. IP packets are typically UDP packets that uses UDP port 500. Right? So once you configure the VPN, your traffic starts coming in, you will see these IKE packets are getting exchanged between the two peers, and then once the negotiation is done, and IKE packets will stop. Now your actual ESP or AH packets are going to start moving in. So let's look at IKE version 1 in a little bit more details. IKE version 1 operates in two modes. They're called, sorry, two phases. They're called phase 1 and phase 2. What happens in phase 1? Phase 1 initially agrees on, phase 1 secures your actual negotiation itself. So phase 1 will typically agree on a set of parameters for encryption, hashing, and then it's going to generate a master key, shared the master key for your symmetric encryption, right? And it will also do the authentication of peers to make sure that you are actually setting a VPN with the right gateway. Right? And then the subsequent phase 1 packets, they're going to be encrypted using the key that you have generated in phase 1 itself, right? And that's your phase 1. And in phase 2 is where you are actually negotiating or agreeing on the parameters that are going to be used for encrypting your actual data traffic, right? So now phase 1 itself can happen in two modes, main mode and aggressive mode. And then so main mode is what I'm going to cover in more details. I think aggressive mode is considered to be slightly less secure, so less used unless you are using a dynamic IP address for one of the gateways. So let us look at what are the configuration elements that you'll have to configure. So let's think about this way. In phase 1, what are you doing? You are establishing a phase 1 SA. That means that you are, both the peers agrees on what is going to be the encryption algorithm that's going to be used, what is the hashing algorithm that's going to be used, what is the authentication method going to be used. Is it going to be pre-shared key, or you are going to use some kind of a certificate to do the authentication? Also, a key element of phase 1 is Diffie-Hellman key exchange. I think we didn't talk much about Diffie-Hellman key exchange. So Diffie-Hellman key exchange is basically a protocol defined by Diffie and Hellman, and what this protocol does is it helps two devices agree on a shared key, the same key, and without actually exchanging the key, right? Exchanging the actual key. What do you do? Diffie-Hellman key exchange has, both the parties in Diffie-Hellman key exchange has a public key and private key. Now A, for example, has its own private key and public key. B also has its private key and public key. So A is going to send its public key to B. B is going to send its public key to A. Now A is going to do is it's going to take its A's private key with B's public key, and they're going to run this Diffie-Hellman function. And then B is going to do just the reverse. It's going to take B's own private key and then A's public key, and it's going to run the same function. And the way this algorithm works is output on both the sides are going to be same, right? So this is very crucial part of the actually IKE negotiation, right? So at the end of phase 1, both the parties are going to have a same key, same symmetric key encryption, master key for the symmetric key encryption. So they are going to use this key to encrypt all subsequent data. So that's going to happen in phase 1. And then in phase 2, so obviously when you're going to configure, you need to configure all these parameters. What is the encryption algorithm to use? What is the hashing algorithm to use? What type of authentication? What is going to be defilement group? By the way, you can have multiple set of parameters. So the devices can negotiate with each other which set is preferred and which set is going to use. But you need to instruct the devices what sets are available for use. And then in phase 2, both the VPN gateways are again going to negotiate, and they are going to agree on what is the encryption algorithm is going to used, what is the hashing algorithm is going to be used for actual encryption and hashing for the actual data traffic, right? And then the packets, the IKE packets that are getting exchanged in phase 2, all of them are encrypted. They're being encrypted using the key that we have generated in phase 1. Also in phase 2, both the parties are going to agree on what is called Proxy Id. What is Proxy Id? Proxy Id defines the network on either side. At the VPN gateway A side and B side, what are the IP addresses are there on either side? They are defined by Proxy Id. So Proxy Id needs to be matched as well. Typically, Proxy Id will be what is called mirror image of each other. We'll look at what does that mean. Okay, and then in phase 2, there is an optional parameter called perfect forward secrecy, PFS. So if you use PFS, then in phase 2, you are going to have second defilement key exchange, and you are going to generate a new key every time phase 2 happens. So that means your phase 1 key is master key is now going to be used for encrypting your data. The new key is going to be generated every time. So it makes your VPN more secure, but it's more resource intensive. So most of the time in VPN implementations, your phase 1, each phase 1 and phase 2 has a limited lifetime. These are also a configurable parameters, right? Normally your phase 1 lifetime is going to be longer. That means you are going to do phase 1 renegotiation less often, whereas phase 2 lifetime is going to be shorter, so that you are changing your phase 2 encryption keys more often. Now let's look at how phase 1 and phase 2 actually negotiation happens. So in main mode, what happens is there are 6 messages gets exchanged between both the gateways, both the parties of the VPN. Let's assume the first party who initiates the VPN, this side is called initiator, and the other side which actually responds to the VPN negotiation request is called responder. So if you use main mode, then in phase 1 there are 6 packets that get exchanged. So what's going to happen in first packet? In first packet, the initiator is going to send a proposal list. So what is a proposal list? Proposal list has a set of encryption algorithms, hashing algorithms, defilement groups, and then authentication that's going to be used. So basically, the initiator A is telling B, the responder, saying that I can support these protocols for phase 1. And also there is a parameter called cookie, initiator cookie. It's going to be, this initiator cookie is going to be set. And then once this phase 1 message is received by the responder, so this is a UDP packet, UDP port 500, and then responder is going to respond with its own IKE packet, which is message 2. In message 2, initiator cookie is going to remain same as what was there in the message 1, and then it's going to add the responder cookie. So cookies are basically a number which is used to track a specific negotiation. So there is no other role of cookies other than tracking a specific negotiation. So if your cookie pairs are same, that means that this is this specific negotiation. All messages for one IKE negotiation will have the same cookie. And then the responder is going to respond with a accepted proposal. So your initiator has sent a list of proposal. Initiator has sent maybe, you know, multiple combinations of encryption algorithm, hashing algorithm, and then responder has accepted only one out of those combinations if it finds something acceptable. If it doesn't find anything acceptable, it's going to reject the proposal and your VPN negotiation is going to fail, right? So at the end of first two messages are called first exchange. You have all the parameters agreed upon for phase 1. So now in phase 1, message number 3 and 4 will have your Diffie-Hellman public key. So in the meantime, A has generated its Diffie-Hellman public key as well as private key, and B has generated its Diffie-Hellman private key and public key. And A is going to send its Diffie-Hellman public key along with nonce, and then B is going to send its own Diffie-Hellman public key. Now at the end of third and fourth message, both sides of the VPN gateway can generate its master encryption key for phase 1. So what device A is going to do? A is going to take A's private key, Diffie-Hellman private key, and the B's Diffie-Hellman public key, and is going to generate a key. And then B is going to do the same thing, and this key is going to be same on both the sides. And now you have a key for master key for subsequent encryption. So now message number 5th onwards, the rest of the messages are going to be encrypted using the key that got generated in after third and fourth packet, right? So that's why this indicates that these packets are encrypted. So what is the purpose of 5th and 6th packet? 5th and 6th packets are for authentication. So 5th packet is going to have as ID, it's called IC ID, and then if there is a pre-shared key, it will use the pre-shared key and it's going to create a hash and it's going to exchange to send to B, and B is going to do the same thing. And if your authentication is successful, then it's going to move to the next phase. So now this is your main mode. Now if you are doing aggressive mode, what is going to happen? Whether you use a main mode or aggressive mode, the messages, the information that get exchanged is same, just that in aggressive mode informations are compressed in a less number of packets. So you'll have just the 3 packets. What's going to happen? A is going to take all the messages in message 1 and message 3, and they will bundle together in a single message. And then the responder is going to send all 3 messages, 1, 2, 4 and 6, and they will put it into a single message and send it to the initiator. And then initiator will send the 5th message at the end, which will be actually the 3rd message, and then your phase 1 is done. Yeah, understood? The type of message it sends is exactly same. I mean the parameters exchange remains exactly same, just that it the initiator now will have just 2 messages and responder will send all the information in a single message. So your VPN negotiation is faster. What that means is also it's less secure, and but you still need to use aggressive mode in a scenario when one of your gateway has a private IP address, or sorry, dynamic IP address. Now we'll look at the quick mode, which is your phase 2. So what happens in phase 2? Phase 2 has 3 messages. In first message, again these are all encrypted, right? In first message, what's going to happen is phase 1 is going to send the proposal list, is going to send a proxy ID, right? It might send Diffie-Hellman key if you are using PFS, and then the responder is going to respond back with the accepted proposal with the proxy ID, and then phase message 3 is going to be confirmation. It's called information message that both the parties has been able to agree on, and tunnel is up, right? So that's how I hope the VPN negotiation is okay, right? We can look at more details when we are actually configuring it. Maybe in my second video I'll show in packet captures how each of these messages looks like. We will actually be able to look at only the phase 1 messages in details. Phase 2s are encrypted. So now let's look at in a Cisco iOS device, how do you configure it? We'll not do the actual configuration. We'll look at the skeleton of the configuration and what it involves to configure it. So in phase 1, actually there are 6 things that you need to do if you have to configure a IPSec VPN in a iOS router. The first thing is you configure the phase 1 policy. So phase 1 policy or ISAC MP policy is where you configure all the phase 1 parameters. So you need to have encryption algorithm, hashing algorithm, authentication method, and DH group, right? And then you need to configure your pre-shared key, right? So that's kind of your pre-shared key for the specific gateway. So kind of your phase 1 parameter configuration is done. And then you will configure your transform set. What is there in the transform set? In transform set you have your encryption algorithm, hashing algorithm for phase 2, right? And then you can configure, you should configure your crypto SEL. What that means, this defines your proxy ID. What devices are on one side of the VPN and what are the devices on the other side of the VPN. And then you will create crypto map where you're going to bind all this information together into the VPN. And then finally you will apply that crypto map into your outgoing interface, right? So let's look at, I'm going to use the same diagram that we looked at before. So if this is your diagram, so I'm going to create VPN between R1 and R2. That means for R1 my peer VPN gateway is R2, which is 2.2.2.2, and for R2 the peer VPN gateway is 1.1.1.1. And what is my interesting traffic or crypto SEL? At one side this is this network, on the other side this network. Now we'll look at what it takes to configure this. So in R1 we'll start with phase 1 parameters. So phase 1 parameter will look like this: crypto ISAC MP. Of course you are going to start with conf t, right? You'll enter into configuration mode and then go start this, right? Crypto ISAC MP policy 10, right? What this means, crypto ISAC MP policy is really your phase 1 policy. And what does this number indicates? Number indicates that if you have multiple policies, the iOS is going to match it in this preference. The lower the number, the higher the priority, right? So for this policy 10 we are using encryption is triple dash, and authentication is pre-share, and Defi element group is group 2. So these 3 are essential parameters. I could also configure lifetime, right? I'm leaving it default, right? Hashing is not shown here, right? You could also configure hashing SHA-1. If you don't configure hashing, the by default hashing is SHA-1. Now the next is pre-shared key, right? In this case, in this line I'm configuring crypto ISAC MP key. Cisco is my pre-shared key for address 222.2, right? This is my R2's IP address. I'm configuring in R1, right? So my phase 1 part of the configuration is done. Now I'll start with phase 2. In phase 2, the first thing I need to configure is what is called transform set. Transform set is essentially my encryption algorithm and hashing algorithm. So I'm configuring crypto ISAC MP IPSec, transform set, transform 1. So this is just a name, and I'm using ESP as a protocol and triple dash, and then ESP SHA HMAC. So I have agreed that I'm going to use ESP, I'm going to use triple dash, I'm going to use SHA-1, and then I need to configure the networks on either side, right? So this is my crypto SEL, which says that for router R1 side the network is 192.168.1.0, and then on R2 side the network is 170.16.1.0. And then I'll go ahead and configure my crypto map. So crypto map VPN 1, then 10 IPSec ISAC MP. This indicates that for this VPN we are going to use ISAC MP or IKE for negotiation. And then set peer this is saying that for this VPN the peer is my R2. I've already defined what is the key for it. And then set transform set, this is the transform set we have already defined here, and my proxy ID is going to be this access list, right? And then final step is applying this in the interface, in the outgoing interface of the router. And R2 almost similar. You'll see that my phase 1 parameters are same. and then appreciate key, just that my address is R1's address now. Similarly transform set, similarly access list, again access list will have local network and remote network is reversed, and then similar kind of stuff, the VPN, the peer is the other party, and then rest of the stuff are same. So that's really the configuration of a VPN in a Cisco device, right? And the reason I talked about configuration a little bit is because I think I'm going to actually going to configure this in my second video, but hopefully you are able to connect this configuration with the theory that we have covered, the phase 1, phase 2, and you will see that parameters are going to be similar to what actually happens. Now please stay tuned. I'm going to have a second video for the part 2, and in part 2 I'm going to cover how do you configure an IPSec between two site-to-site IPSec VPN between two Cisco iOS routers.